So now let us come to Carnot's theorem. So already we have discussed the efficiency of a Carnot engine. Let us just recall it. So if we have a reservoir at T1 temperature, or that is a hot reservoir, that is a source of heat. So a Carnot engine takes Q1 amount of heat from this and rejects it to sink at T2, that is the cold sink, and the remaining amount of work, that is equal to Q1 minus Q2, all these are moduluses, is converted into work. So important point about this is efficiency of a Carnot engine eta is given as, so efficiency is work output we already know by the heat input Q1, that is equal to Q1 minus Q2 by Q2, that we got Q1 minus Q2 by Q1, this is Q1. So that is, we got 1 minus Q2 by Q1. So already we have calculated that this Q2 by Q1 comes out to be T2 by T1. So this is the efficiency of a Carnot engine, or it is, let us write this. Now, so this efficiency is 1 if T1 is 0. So if T2 is equal to 0, then the efficiency of a Carnot engine is maximum. So the efficiency is maximum. So what is important point about this? Very important, so I am marking it. Carnot engine is a reversible engine. Very important point. Carnot engine is a reversible engine. So these are important points. Carnot's engine is a reversible engine and efficiency is given as 1 minus T2 by T1. So what is Carnot theorem? So according to Carnot's theorem, a reversible engine will have the maximum efficiency. So according to Carnot's theorem, a reversible engine will have a maximum efficiency working between the given source and sink temperature. So if the source and the sink temperature is same, no other engine can have a better efficiency than a Carnot engine, that is a reversible engine. So between two source and sink temperature, the maximum efficiency engine will be a reversible engine. This is what Carnot cycle is, Carnot's theorem. Let us prove it now. So now let us take two engines. One is the Carnot engine, which is a reversible engine, that I will denote by R, and an irreversible engine that I will denote by I. So that is, so you see here we have the same source, suppose I say T1, and we have the same sink for both engines, that is at T2. So this is one engine, that is irreversible engine, and it is denoted by I. What is its work? It takes Q1 amount of energy, rejects Q2 amount of energy to the sink and does some work, W. Next, we have another type of engine which takes Q1 dash amount of energy, rejects Q2 dash amount of energy and does some work, W dash. This engine is a Carnot engine, so I am writing it R. R means reversible, I means irreversible engine. So this is a Carnot engine. So this is a Carnot engine. Carnot engine in bracket reversible engine. And this is irreversible engine. So let the irreversible engine I and the Carnot engine R is working between the same source and sink temperature, source and the sink temperature. Let eta, the efficiency of I, is greater than eta dash, the efficiency of R. So I have eta greater than eta dash. Let us compare the efficiencies. We assume that this I is more efficient. Here one thing, let us assume here that the work done by both the engines is the same, so that we can easily compare it. So I will assume that this work W and W dash is same. So this and this is work. So let us assume that the work done by both the engines is the same. So this is work done by Q, this is work done by Q1 dash. So work done is here same, implies Q1 should be less than Q1 dash. That means if this engine is more efficient, it should take less amount of energy and convert it to more. So I got Q1 is less than Q1 dash. So now we have seen that this efficiency is more than this. Now again what we do, this is a reversible engine, so let us operate it in a reverse mode. It cannot be operated in a reverse mode because this is a irreversible engine. But since my Carnot engine is a irreversible engine, we are going to operate it in a reverse mode. That means the work done this is, so this means this time I am going to use this as a refrigerator. So refrigerator requires work, and this work I will give from this engine. So now let us use this engine I, which is doing the same job this time also. It is converting energy into work, but this time my reversible engine is reversed. So I have given work of this engine to R, and it is taking Q2 dash amount of energy this, and it is rejecting Q1 dash amount of energy to this. So now let us use the Carnot engine in the reverse mode, i.e. the output W of the irreversible engine of the I engine is given as the input to R. Now R acts as a refrigerator refrigerator. So it takes Q dash amount of energy. With the help of work, it gives it to Q1 dash. So let us see what happens, what this system is becoming like. So now let us see, summarize what is happening here. So this is my source, which is a hot reservoir, and this is my sink, which is at T2 temperature lower than this. So you see, Q2 amount of heat goes here and Q2 dash goes. That means I can say that there is a net flow of heat. Net flow of heat, that is Q2 dash minus Q2 from here. What happens to this? Some enters heat enters into the system, and how much? Q1 dash. This is Q1 dash minus Q1. So Q1 dash minus Q1 heat enters in this system, and there is no work done from the external source. Now you see, Q1 dash and Q1, and this is Q2 and Q2 dash. What we observed that Q2 dash minus Q2 amount of energy is taking from sink, and Q1 dash minus Q1 amount of is going to the sink source. Now already we have seen that since efficiency of N is greater than N dash, so Q1 is less than Q1 dash. So this quantity is more than this. That means this is equal to a positive quantity. That means some positive, suppose it comes negative, that means it is going in this way, it will be there. So by assuming the efficiency of this engine is more than this, I got that Q1 is less than Q1 dash. So this quantity is positive, means heat is actually going, and now you can see these two quantities are same. How we can see? So Q1 dash minus Q1. So Q1 dash minus Q1, let us see this quantity. Q1 dash is equal to W plus Q2 dash minus Q1. Q1 is Q2 plus W. Q2 plus W. So this is W plus Q2 dash minus Q2 minus W. So this cancel. We have Q2 dash minus Q2. This is the same thing. That means this heat is equal to this, I have proved. This quantity is positive. So what is the result? The net result is that the heat flows from the sink to the source without any external help, which violates the second law of thermodynamics. That is the clausius statement of the second law of thermodynamics. Thus, our assumption must be wrong. What is my assumption? That a irreversible engine has more efficiency than the R. Thus, the Carnot theorem is proof that this R will have more efficiency than this. Let us write this now. Now, thus the end result is the heat flow Q1 dash minus Q1 from a lower temperature T1 to a higher temperature T2 without any external work done. Thus, it violates the clausius statement of second law of thermodynamics. Hence our assumption that a irreversible engine a irreversible engine has a more efficiency than a reversible engine is wrong. Thus the Carnot engine has the greatest efficiency working between a particular temperatures. This is the Carnot's theorem.